Hello, the first question we're going to be going over today is Module 4, Question 1, Word Finder Puzzle. This is definitely one of the most important questions from this module, and you have a homework question that's really similar to this. So I'm going to be going through the tutorial question, and what I'm going to be doing is take you through the question, and I have the solution right here. This is copied from the solution video of the tutorial, and we're kind of going to get an idea of why we are writing the code the way it's given and how to change it according to the question. All right, so let's get started. Okay, so this is my word puzzle. Okay, you're going to write a script to find a word from a puzzle. In general, the game is designed to search for multiple words. However, in this problem, you can write a program to find only one word, banana. So that is my word. This is just a simple banana. I wrote a code to create a word puzzle and insert banana at a random column or a row location. That's the one that has been given to you right here. Okay, and what does this say? This means banana is not located at a diagonal direction. Okay, so all I have to check is in from left to right or up to down. All right, you need to create a variable named wordlock that contains a 6x2 matrix. Each row of wordlock contains the location of each character of banana in order. Column 1 is the row location and column 2 is the column location. All right, so this is just a rough drawing of what my puzzle would look like. This is a bigger puzzle, so I've just drawn the first 7 rows and columns, and suppose my banana is located like this. So in my wordlock, what I would be writing is, if my banana was located like this, I would want my first column of banana to be all 2, 3, 4, 5, 6, and 7, and the second column to be 1. So basically, your first column is storing the row locations and the second column is storing the column locations. All right, that's what the question means. And what else? Yes, that's it. You need to start writing your code. Great. So let's keep this as a point of reference for us, and also let's take a look at the given code. All right. So the first thing I've done here is kind of basically just pasted the given code, and I'm going to run this. All right. So if I expand my command window, I can see this is my puzzle. And if I look at my puzzle, I can see my banana right here. Perfect. Okay, great. But now I need to figure out a way for MATLAB to find this word. Okay, and let's take a look at the other things we're given. We've been given n word, which is the size of the word banana. We have the puzzle, which is a 10 by 10 double. So if I click on this, what is this basically? This is this exact same word puzzle, and these are the ASCII values of the words. Sorry. Yeah, these are the ASCII values of these exact letters. Okay, so this is just the word puzzle in the double format. Okay, the puzzle size is 10, which is basically telling you that the puzzle is a 10 by 10 matrix. The word is banana, and word DB is banana, but again in the ASCII notation, and wordlock is an empty 6 by 2 thing. This is the one I need to fill up with the word location of my banana. All right, so I am going to be copying a big yes, and I'm going to be not uncommenting them. All right, so now that I've done that, let us walk through the solution. Okay, the first thing we've done is we've defined a word lock. It is a 6 by 2 double vector matrix, which contains zeros. All right, so that is where I need to store my data. This is what word lock looks like, and it's full of zeros. Okay, now the first variable we have right here is isRun equals true. Why we are defining an isRun here is basically, as if you look at the question again, there is only one word banana. So if I've already found the word banana in my columns, I don't exactly need to check for it in my rows again, right? This is why we have one section of the code that searches the column and another section of the code that searches the rows. So here, before I search my columns, I have a variable that is called isRun, and it's set to true. If I find my word within the columns, isRun becomes false, and if I have found it in my columns and isRun is false, I'm going to start my search rows code by saying if isRun. So if I've already found it in the columns, this is going to be a false, and none of this is going to run because I don't need to look for banana within my rows. I've already found it within my columns. All right. So that is the reason we're using is run. Okay. So the first loop we start with in the columns is for I equals 1 to puzzle size. Okay. So that is basically looping me from 1 to puzzle size. We'll see in which direction soon. Okay. So now we have the first thing. This is called callback. It's puzzle, all rows, ith column. So for the first run, the ith column is going to be 1, and then it's going to keep increasing by 1. So basically, callback is us isolating each one of these rows, one of these columns, sorry. So the entire column is, wow, that's a bad line. So the entire column is isolated by callback. So when it's a callback, is going to be something like callback when I equals 1 is basically the first call. All right. So it's going to be a big column. It's going to have 10 letters. And it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And we have banana like this, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And if you take a look at this, we have our banana right here, B-A-N-A-N-A. And the rest of them are going to be filled with, I don't know, like random digits. It's going to probably could be X, Y, something. So that we have an X here, we have a Y here, we have an M here, a Q here, something or the other. All right. So this is a really important concept. Using callback, we are basically isolating each row of each column of the vector when we are looking for columns, and then searching for the word banana within the column. All right. That's a really important concept, and you should really make a note of that. All right. Next, what are we doing? We're saying for JJ equals 1 to puzzle size minus n word plus 1. All right. So this is a bit confusing, but we're going to come back to why we did this in a while. Let's start with this. Test log equals JJ plus n word minus 1. All right. So for my first run, my JJ value is, say, 1. Okay, so let's see. JJ plus n word minus 1 equals 1 plus 6 minus 1, that is 6, which is basically giving me the length of the word banana. All right. If I had not subtracted the 1 from it, it would have given me 7, which is not the right length. Okay, which is why we need to add n word and then subtract the 1. So now what is my test location? It's JJ to JJ plus n word minus 1. So my test log is a range, and the range for the first iteration is 1 to 6. So that's 1, 2, 3, 4, 5, 6. That's exactly the number of digits there is in banana. Okay. And then what do? We say test word equals callback, and what part of callback? The test log. Okay. So that refers to the first to the 6th element of callback. So that starts at 1 and it goes till 6. So it's these 6 letters. Okay. So now what we're going to be doing is we're going to check if the word DB, which is my word banana, is equal to test word transposed. Why transposed? Because word DB is a row vector. This is a row vector. And since we are looking through columns right now, all of this is a column vector. Also, right now I'm writing it in terms of letters because it's easier for us to imagine. But as you can see here, that MATLAB stores everything in numbers, right? So it can compare the numbers directly. It stores all the character values as ASCII values. Okay. So this is why I need to transpose my callback. And my if statement is going to check if is equal word db equals test word transpose. So in this situation, we have x, b, a, n, a, and a, n. That's not banana, so that's not going to work. So this loop is not going to run. We're directly going back. So it would go here, and then it would skip back to the j loop, right? So now my j value is 2. My test log becomes 2 to 7. So now my test log has a new range. Instead of 1 to 6, it is now 2 to 7. All right. So this is my new test log. So what is 2 to 7 right here? So it starts here and it ends here. So this is my new range. All right. And my test word is basically callback test log. So basically this word is stored in test word. So now we check if is equal word db comma test word transpose. My word db is banana. My test word transpose is also banana. That is a true. So now I'm going to be shifting to this. So what does it say? Word log, all rows, second column equals II. If you remember, the j value changed because we looped through it again, but my I value is still 1. My I value is still 1 because we're still in the first column right here, right? This is still my I is 1. Okay? Therefore, what does it say? The second column of word log is going to be full of II. Okay, let's do that then. So this is all going to become ones. And my word log first column is going to be test log. What was my test log? It was a range. My test log was a range of 2 to 7. So this is also going to be like that. So 2, 3, 4, 5, 6, 7. All right. And now let's think about it. Is this what we wanted exactly? Yes, because as the question said, the first column would have the row location of the word banana, and the second column would have the column location. So for B, we have 2, 1, 2, 1. For A, we have 3, 1, 3, 1. C, and then so on and so forth. Okay, so this is the right assignment. So that is exactly what this loop does. And once it has found the word, is run turns to false, and we break out of all the loops. So now we're at the we're out of the whole for loop. Now when we go to search the columns, since the word has already been found in the columns, we don't need to search the rows. So is run is false and we don't search the rows. All right. Now in a situation where this was not stored in a column and this was suppose stored in a row, suppose I had my banana like this, like B, A, N, A, N, A. So what would change? Would I store it in the same way? Not exactly. Because right now, if you take a look at it, the column remains the same, but the row changes, right? So if I had to store this in word log, it would be 6. So it would be something like this. My new word log would look like, so if this is it, 1, 2, 3, 4, 5, yeah. And this one is also still banana, right? So B, A, N, A, N, A. My first column, my second column. In this situation, this should be 6, 3. So this should be 6, 3. And then it would be 6, 4, right? So my first column would remain the same and my second column would change, right? This would be 3 till 8. So when we are looking through the rows, we keep it as the same code, but we flip how we store it in the word log. So when you're storing the columns, your second column remains the same while the first column is the test log range. But here, your first column remains the same while your second column is the test log range. All right. So that is definitely very important. And another thing is that, okay, so here we were searching for columns. That's why my test word was in the form of a column, which is why I needed to transpose it right here. If you take a look at this, here I was transposing it to check if it was equal, and here I was, yeah, that's it. And in this particular one, since you're looking for rows, Your word DB is a row and your test word is also going to be a row, so you don't need to transpose it. All right. So that is the concept of this question, and it is very important. Take some time to understand how you loop through a vector or a matrix to kind of search for your word. And yeah, so go over that concept very carefully. Okay, I think I forgot to mention why we did this. Okay, that is also a really, really important concept. Okay, so if you take a look at this, what were we doing? We were defining the test location to start at J and go till J plus n word minus 1. So we could kind of find all the words with the same length as banana, right? So when we started at 1, we went till 6. When we started at 2, we went till 7. So now let's keep doing that. If I start at 3, I would go till 8. If I started at 4, I would go till 9. If I started at 5, I would go till 10. But now look at this. If I started at anything beyond 5, if I started at 6, wouldn't it give me an error? Because there is no 11. There is nothing here. So it would give me an error. I cannot start beyond 6. That is exactly what we're doing to limit the J loop right here. We are starting at 1, and then we are going to puzzle size minus n word plus 1. So what's my puzzle size? My puzzle size is 10. My puzzle size, sorry, I think there's an underscore right here, equals 10. My n word is 6 because that's the length of banana. And what am I doing? I'm saying 10 minus 6 plus 1. So that is equal to 4 plus 1, which is 5. And that is exactly where I need to stop, right? Anything beyond 5 would give me an error. So that is how you limit your J loop. Okay, I hope you're comfortable with this question, and if you have any other questions about this, please feel free to ask us during office hours. So now I'm going to run this code once. Now that we have the whole code, I'm going to run it. There you go. The word you found is banana. And if I take a look at my word lock, it is a 6 by 2. And if you take a look at right here, do you see the banana here? It is 1, 2, 3, 4, 5, 6th row, and first column till the 6th column. Is that what my thing is? Yes, it's all of this is the 6th row and the first to the 6th column. Perfect. So the next question we're going to be reviewing is module 5, question 8, equipment purchasing. So there's multiple questions within module 5 which are really similar to this question. So if you look at the contents, there is baseball stats, and then there is baseball stats 2, there's course grading, and there's this one. All of them are very similar questions. I'm just doing this one because it's a 3-star problem, so it's slightly harder than the rest of them. You can attempt all of them. All right. Okay. Let's get started with this question. You have a bunch of different variables that are declared here. This is, I think, the number of pressure gauges, the number of gate valves, concrete molds, batteries, pumps, venturi meters, gyroscope sensors, all right? And all of these are 5 by 1 vectors. So they are 5 rows, 1 column. Okay. And the annual purchases are grouped together in this one big vector called and purchases. So I have made my and purchases vector right here. It is 5 rows and 1, 2, 3, 4, 5, 6, 7 columns. All right. Okay. A very, very important thing to note is this line. So last time during the quiz 1, this was part of your last question, which a lot of people missed. So when we write something like clear vals and then we clear a bunch of different variables, that means those variables are completely empty. They have been deleted. You cannot be referring to them anytime in your question. If you want to access the data from any of those variables, you need to use your main matrix, which contains data from these variables. These variables are deleted. They have no values within them, all right? So please be really careful when you're doing a question like that. And this is the cost of the individual equipments, all right? So the matrix and purchases gives how many of each type of equipment has been purchased each year over 5 years. Each row of and purchases corresponds to a different year. All right, so I have labeled them as year 1, year 2, year 3, year 4, and year 5. All right, okay. And the cost of equipment is provided in equip costs, which is a 1 by 7 row vector. The first element of equip cost is the price of a pressure gauge. The last element is the price of a gyroscope sensor. All right, so by that logic, this is going to be the cost of a pressure valve. This is the cost of a gate valve. This is concrete mold, battery, HP pump, venturi meter, and gyroscope. All right, so that's the order. Okay, so write a script that creates a variable named. Okay, the first thing I'm going to do is copy all of this given code. So I'm going to take this and I'm going to paste it right here. Okay, so before I start writing any of my own code, I'm going to run this. And if you take a really careful look, do you see any variables called numpg, numgv, cmb? No, there's nothing like that because they've been cleared and deleted. So be really careful. Run the given code, see what you have, and then work with it. Okay, and I have my and purchases, which is a 5 by 7 vector. Great. All right, so I'm gonna clear that right now because I don't need to see any of that. Okay. And what am I gonna do? So let's take a look at part A. So min cm, which contains the fewest number of concrete molds purchased during 5 years. So the variable name is min, and it also tells me it should contain the fewest number. So that takes me to the built-in function minimum, right? So min. So I'm going to define right here. I'm going to say, oh, right here. Okay, let's start with it. I'm going to say part A. And the variable name I have is min underscore cm. And this will be equal to fewest number of concrete molds purchased during the 5 years. So if I take a look at my and purchases, where are my concrete molds? My concrete molds are this. Let's take a look at this. Oh, this should be cm. I wrote them as gm, my bad. Let me erase that right here. This is a cm. So these are my concrete molds. This is the column I need, right? So I'm going to be writing here the minimum value from the third column of and purchases. So annual purchases. Oh, I spelled purchases wrong right here. Okay, how do we refer to the third column? So all rows, comma, third column. All right. Yeah, make sure all your brackets are closed. So there's a bracket for this and there's a bracket for the min function. And that's it. That's my part A. Let's move on to part B. Okay, so part B, what does it mean? It's max V, which contains the largest number of venturi meters purchased during the 5 years. So largest, that takes me to the function max. And which column is the venturi meters? Column 6. So it's this one. This is the column I need to refer to, right? Okay, so let us define my value. What's it called? Max V. Okay, max V, and this is equal to max of, and it's the exact same format, but instead of the third column, I need the sixth column. Okay, so that is my max V. Moving on to part C. All right, so see, min year B, which contains the year when the fewest batteries were purchased during 5 years. Note that if there are more than two minimum numbers, please assign the earliest year. For example, the fewest batteries are purchased in year 1 and year 2, you need to assign 1. Okay. An important thing to note here is they're not asking for the minimum value, they're asking for the minimum year. So we need to give the corresponding index value, so the corresponding row value, right? So if you take a careful look at your notes from max and min, there is a way to do that. And what's the format for that? So we need a bracket, and we have this, comma. What's the name of my variable? It's min year B. And this will just be my minimum annual purchases. So copy that right there. And what's the question? This is fewest years about batteries. Which column is batteries in? Column 4. So I change this to column 4. Okay. Storing indexes is an important concept. So please make a note of that. Keep that in your notes while you're giving the quiz. Okay. Now we move on to part D. Okay. Max purchases in, which contains the year of the highest number of every purchase. So even once again, we have max purchases in, which contains the year. So once again, I need to refer to my index instead of the actual value, which contains the highest number of every purchase. So this is basically, I need the index value for the entire matrix, right? Max purchases in is a 1/7 row vector. If the maximum items purchased is the same in multiple years, return the lowest year number that has the maximum items purchased. Note that if there are more than 2 minimum numbers in each item, please assign the earliest year in each item. So this format automatically gives you like the first minimum value, so you don't have to do anything extra for that, okay? So since this is a 1/7 row vector, you want the minimum value of the whole matrix, so every single column. What I'm going to be doing is I'm going to write the exact same thing. So I'm going to write this. I'm going to write, what's the variable name? Max purchases in. Okay, max. Okay, and this is going to be my max for the entire vector, because now I'm not trying to isolate a single column. I want the max for all of the rows, all of the columns, sorry. Okay, so that is my part D. Let's move on to part E. So max year, okay, which contains the year with the maximum total number of items purchased during 5 years. So let's take a look at the example to understand this better. For example, Anne purchases is 1113, 1124, 223. Okay. Max purchase years becomes 3 because year 1 to 6, year 2 is 8, year 3 is 9. Okay, note if there's more than 2 maximum numbers, please assign the earliest year. So what I basically need to know is kind of add everything in the horizontal direction. So this is 3 plus 3, so that's 6. This is 1 plus 1 plus 2 plus 4, that is 8. This is 2 plus 2 plus 2 plus 3, that is 9. So what we're doing is basically adding all the rows in the horizontal direction, and then whatever is the maximum, that is what I need to store in max year, right? So the first thing I'm going to be doing is making a vector, and this should have the sum of each of the rows in the horizontal direction. Okay, so I'm going to call it sum of items. I'm just going to give a little, yeah, there you go. So sum of items equals sum, and it's and purchases, but this is in the horizontal direction, so I have a comma and I say 2. All right, and this is the, then I use this exact same format. So I'm going to copy that, and I'm going to change all the variable names. So here, instead of max purchases, it's going to be max year, and here instead of Anne purchases, it's going to be sum items. All right, exact same format for both of them. All right, moving on to question F. Is more than 1200, which contains logical 1, if the total number of items purchased during 5 years are more than 1200. Otherwise, assign logical 0 to is more than 1200. We're going to compute the cost using the price for each equipment provided in equip costs. So this is where we start using this particular vector, equip costs. Okay, so what do I need to do? I need to add the total. Oh wait, this is part F, right? Actually, No, we're not going to be using equip cost for part F. We're going to be using that for G, H, and I. My bad. Okay, so here we're just adding the total number of items purchased during 5 years. So that is easy. I just need to sum everything from and purchases, right? So I'm going to store that in a vector called total items that kind of just sums up everything I have. And this is equal to the sum of and purchases. So and purchases. And I'm going to say all because I want the sum of everything. So that's the format for it, syntax for it, sorry, and all. Okay? So this basically gives me the sum of every single value within that and purchases matrix. And then I need to check if that is greater than 1200. So I'm going to say is more than 1200 is equal to total items greater than 1200, because that's the condition I'm looking for, and that's it. Okay, this is the section from where we start using the cost price provided in equip cost. So equip costs, as you know, is a 1/7 vector which contains the price of each of the equipment. So out of these three questions, I'm just going to do the G part because I feel that's the most relevant one. You can try out H and I after that, and if you have any questions, approach us. But they're fairly simple questions and pretty similar to each other. All right? Okay. So it asks us to create a variable named total cost, which is a 5x1 column vector, and determine the total cost of equipment in each year. Use the equip cost vector and purchases to calculate the total cost. All right, so I have my and purchases vector right here. So I have my PG, CV, CM, whatever. So these are my different kinds of equipment. This is the year that I've purchased them in. And this is a 5x7 vector because it's 5 years and 7 things. So if I look at my equip costs, this is a 1/7 vector. And you have your 15 here, you have your 20 here. And how does this correspond to your and purchases vector? So 15 is the cost of your pressure gauge. 200 is the cost of your, what's it called? Gate valve. And 5 is the cost of your concrete mold. 5 is the cost of your batteries. 95 is the cost of your HP pumps. So each of these values kind of corresponds to the respective column in your and purchases matrix, right? However, can I multiply them directly? Not exactly, because this is 5/7 and this is 1/7. If you remember, we have learned that for two vectors or matrices, for us to be multiplied, so if I have an m/n matrix and I have another matrix that's a p/q, I need my n value to be equal to my p value, and the answer, only if these two are equal, is the multiplication possible. And if it is, then my answer would be an m/q value vector, right? However, an interesting thing to note here is that, so this is a 5/7 and this is a 1/7, and my answer should be, according to the question, this should be a 5/1 column vector. So instead of handling like this, what if I transpose my equip costs? So after transposing my equip costs, it looks like this, and it's a 7/1 vector. So now let's think about it. My 7 matches with this 7, so the multiplication is possible, and my answer would be a 5/1 vector. That's exactly what I want. And let's think how vector multiplication works. So it's going to work this way and then this way. So the first element is going to be multiplied to 15, and then it's going to add that to the second element multiplied by 200, the third by 5, fourth by 5, then 95, 175, and 3. And that's exactly what I want, because the price of this particular equipment is 15 and the price for the second one is 200. So that works out well. So what I need to do is basically multiply my and purchases by the transpose of equip costs and store that in my answer. So what variable do I need? It's called total cost. All right. So total cost equals and purchases multiplied by equip costs and the transpose of that. All right, so this is all I am going to be doing for this particular question. If you have solved your homework properly and if you've gone through the tutorials, you will notice that this question is really similar to my earthquake stats question too, right? So when you're revising your homework for questions, I would highly recommend kind of figuring out the different variations of it and looking at similar questions from module 5 to kind of understand how that works out in the same concept. All right, so here if you take a look at module 5, there are multiple similar questions which kind of look like the same. There's batting stats, baseball stats right here. This is a 2-star question. It's slightly easier and it has the same concept. It has a vector like that, and you will be asked to perform a bunch of different calculations according to the conditions right there. So baseball stats is there. There's another baseball stats too. That's also a 2-star question. And I think course grading is also a very similar question. So definitely make sure you take some time out to practice these concepts. All right. Yeah, this is course grading too. Hello, so the last question I'll be reviewing today is one of your old homework questions. This is from homework 2 question 5, is a 2D point inside a box. The reason I'm reviewing this is because I have not given you a lot of homework questions or tutorial questions to practice from modules 1 to 3. It's pretty much based on your discretion, the questions you have had a hard time with, the concepts you find problematic. I'm discussing this question because a lot of people had this question when we were doing the homework, and then a lot of people also got stuck on this during quiz 1 because that quiz 1 had a similar question. So having this concept clear would also help you in your future quizzes. All right, so let's take a look at this question. You are going to write a code to check if a 2D point is inside the box. The x and y coordinate of each point is stored as a 1 by 2 row vector and is randomly generated from the interval of 1 to 10 in the x and y directions. The x and y coordinates of point 1 and point 2 are stored in the variables named pt1 and pt2 respectively. So here we have our pt1 and we have our pt2. Please be very careful when you read your quiz questions. You will usually have a comment next to it that tells you exactly what that particular thing is. So here it says pt1. There is some sort of a code here which might be confusing to you, but you should read the comment. This is a 1 by 2 row vector generated in the interval of 0 to 10. So you know that what point 1 is, and you also know what point 2 is. All right, and check if point 1 is inside the box. If yes, true is assigned to the variable named is point 1 inside, otherwise false is assigned to the variable. All right, so if we look carefully, point 1 and point 2 are 1 by 2 row vectors. So let's draw that out. I have made a rough sketch of how my points should look, and I'm going to write my point 1 and point 2 here. So I think it's an underscore. No, there is the underscore. Okay, pt1. This is a 1 by 2 row vector, and so is pt2. So now it's clear to me that there are 2 values per vector, and this first row, this first column contains the x coordinate, and this contains the y coordinate. So this is the x coordinate, this is the y coordinate again for point 2. All right, so you need to be really careful about that while you're writing your code. Okay, so let us copy the given code right here and paste it in our MATLAB. All right. Okay, so let's take a look at our box. So we have our box and it has these bounds. So in the x direction, the bounds are 2.5 and 8.5. In the y direction, the bounds are 2.5 and 6.5. Okay, so what I'm going to be doing here is kind of make a vector. I'm going to call it b box, and this is going to store my bounds. The first 2 bounds are going to be the bounds in the x direction, and the second 2 are going to be the bounds in the y direction. So I'm going to say 2.5, and then I'm going to say 8.5, and then I have my 2.5 again, and I have my 6.5. All right, so these are the 4 values that kind of form the outline of my box, right? Okay, so let's start with my part A. what does it say? If point 1 is inside the box. Okay, so if you look at this one diagram, we see there's one point that is inside and one point that is outside. So if I show you this point, you will automatically tell me this is outside the box. How did you determine it? The way to go about that is first check if it's within these two bounds. This one actually is, so that is within the bounds in the x direction. However, when you check if the y coordinate of this is within the bounds of the y direction, you find out no, this is outside. This is probably a 7.5 or something. So maybe this point is, let's say, 8, 7.5. So 8 is between the x coordinates, but the 7.5 is beyond the y coordinates. So this point is not inside the box. However, at this point, let's call it, I think it looks like, say around 3.5, 6. So now if I check the coordinates of this point, I would find that 3.5 actually does lie between 2.5 and 8.5. However, 6 also lies between 6.5 and 2.5. So that's perfect. My point is within my box, right? So you need to check for the x coordinate as well as the y coordinate, your x and your y, okay? So you need to be really careful about that. Okay, so let me write my variable name. It's called is point 1 inside, and I'm gonna say, okay, so like we said, I first need to check if the x coordinate is within the box, and I also need to check the y coordinates are in the box. Okay, so I'm gonna say point 1, 1, this is my x coordinate, remember, is greater than b box, b box 1. This is my boundary for in the x direction, and my point 1, 1 is less than b box 2, right? Okay, so that covers my x direction. Now the y direction, that should also be satisfied. So all of these conditions should be true, which is why I'm using and between everything, okay? So now we move on to y. So point 1, y coordinates should be greater than b box 3, and point 1, y coordinate should be less than b box 4. Okay, there I have all my 4 conditions, and that is the answer to if my point 1 is inside. So now I'm going to copy this whole code. I'm going to copy this right here, and I have my part B, which is trying to check if point 2 is inside, and I'm going to just edit all the point 1s to point 2s. So this is going to be 2, this is going to be a 2, this should also be a 2, 2, 2. Okay, I'm gonna do one final check to check if I've already altered all of my variable names. I have, so that's a good. And now let's go and check for part C. Okay. Okay. At least one point is inside the box, and true is assigned to a variable named isPointInside. Otherwise, false is assigned. So my variable name is point inside, and I need either one of these points to be inside the box. So either this or the other one. That way, I'm going to use my logical operator OR, and the two variables inside are going to be is point 1 inside, comma, comma, and the second one is going to be is point 2 inside. All right. So be very careful when you're checking for your, be very careful when you're using the different conditions, if you're using a logical AND or a logical or a NOT, and also be very careful while using all of these variable names. Sometimes it's really easy to go wrong. Sometimes you'll give an extra underscore in between some of them and your code will stop working. So be really careful while doing that, and also proofread your questions, okay? Check your questions alongside the given question. So sometimes make sure you have your correct variable names, make sure you have your correct data points, make sure you have this 2.5, 8.5, 2.5, 6.5, things like that. you really need to keep an eye out for that during the quiz because you don't want to lose marks on really small stuff like that. All right. So let's run this and we are going to copy paste that into our, oh, not everything, just this. There we go. And submit. Great. Hi everyone, thank you so much for watching your quiz 2 review video. All the best for the quiz. I'm very sure you guys are well prepared. Don't second guess yourself. You know the answers. Just concentrate and try to figure out how to apply everything that you've learned. As I've said before, I would highly recommend watching the quiz 1 solution review video. You can find this right under all of these lecture videos and homework review videos in your GitHub. So make sure you take a look at that. And if you have any questions, feel free to contact us. All the best.